So check out this. What I found. I changed everything to bouncy, and I've given them another little bit of an action space. They can actually move in not just in relative positioning, but in global positioning. So up, down, left, and right. I made the walls solid, so they bounce off the walls, or they just hit the wall and stop. But on this one I chose bouncy walls. I could just do like a friction coefficient or something like that. But the point is, take a look at this yellow guy. So there's 3 in this simulation. There's 3 predators. This guy is the second best, the light blue one. The worst one is the orange guy, making 7 points where the yellow has already scored 57 kills. So they get a reward for each time they kill. That's like 200 point reward, and the opposite reward is given to to whoever dies. So they learn their lessons pretty harshly. Otherwise, they get a little. The prey get a little bit of reward for sticking together, and the predators get a little bit of reward for being near prey. So you'll find it sometimes they just like stop. That's not like a coding thing. I've definitely checked this. It's not a fault of having no neighbors or something like this. It's literally that they learn pretty quickly how to slow down to a stop and then just choose do nothing. So that's interesting because they sort of just wait for something to come around close to them and then wait for their moment and then pounce, Sometimes you'll see them inching closer to each other or things like this that are kind of weird, to get better positioning. So, but if you watch during this video while I'm talking, if you watch the yellow guy, the yellow predator, and the orange predator, they are the best ones. There's also going to be an orangish guy who's prey. There's I think it's the most orangish looking one. It's kind of hard to tell with them because their life is shown, how much life they have left by how much filling they've got left on the inside. I think it's this guy, who's roughly the same orange as the predator. So far he's had the least deaths, only 10 deaths, while everybody else has been suffering in the teens and in the 20s. So you can see that prey also has a strategy that works out really well. Yeah, I mean, this is not to say that they get better or worse during this entire time. Like if I run the stats again, I'm running it down below in a console window. For instance, the yellow guy has got 104 kills, while the orange guy only has 22 kills. And I think what the orange enemy is not really getting is, if you look at the difference between these two, yellow has figured out how to stop just exactly so that it is able to attack the most amount of times, just over like when somebody is passing it, while orange hasn't quite grasped that stopping method yet. It tries to do some other tricks, but those tricks are definitely not as efficient, even though it still gets a score. This light Arctic blue thing is, he's one of those who just is in the middle somewhere. He's got 58 kills, so he's doing about half as good as the yellow, and 5 times better than this orange guy. Whereas his orangey counterpart, if you follow them, I mean, looks wonderful. And they also have been able to take advantage of bouncing, which is really interesting. Sometimes they stick near a whole bunch of For instance, a predator will stick near a whole bunch of prey that's near the edge and wait for them to bounce and just grab them off the bounce. Technically, they don't have any situational awareness, like actual location of where they are on the page. Everything that they see is just the relative vector towards the neighbor and all of the dimensions that they use. So that's the vector that they use to make decisions. They basically look at each neighbor, and then they go by each neighbor and make a decision that changes their velocity vector. Now, this is not hard-coded in. The velocity vector stuff and all that stuff is just inside of actions, which is part of config inside of my Progeny JS file. So really, this entire visual that you're seeing and the entire simulation is set up really inside of the index.html file and not within the progeny.js file, which just is really the structure for this entire setup, so that it's easy to get a multi-agent system like this running. But yeah, I'll just leave it going here for a sec so you can watch. Also, by the way, these can see up to 2 neighbors. I've restrained it so that they don't get too confused as to who they want to follow. I could also make it so that the prey can see more neighbors, or it can see further away, and the predators could see less neighbors and stuff like that. I've just made an init function callback, so basically init happens after after you've already set up all the cells and during the start procedure, so that you can run through the cells and change any of their properties during the init phase just before it starts. And that way you can do stuff like, I don't know, plenty of stuff. I think personally on this one, I forget what I was trying to do. Just do something based off of whether or not they were predator or prey, give them some sort of a slightly different other feature. And all these features are just inside of a linear list. They don't have any names, these dimensions, so to speak, unless they're given one. But they can be used for any aspect of the visualization of the game, or just the dynamics between the players, well, the AI players, so to speak. But yeah, that yellow guy has definitely hit some level of mastery on getting inside of this specific bouncy context. He just, when yellow passes one, you notice that they almost lose all their life. Whereas when orange passes one, might not even really phase them, because it doesn't take that, it doesn't do that little. Pretty sure if you were to watch this in slow motion or something, you could see yellow slows down ever so slightly and then speeds back up to see if it can like trap the other cell. Man, it is just going. And usually when it, like, you see that, it's eating full life prey with full life, and it never sits still. It, every once in a while, it just like glides around ever so slightly. And orange is sort of like getting it and stuff, but he just lets too many things pass him, and then, I don't know, gets confused or something. But yellow is totally on it. It just glides over them at some specific speed and eats all it wants. Anyway, I'm gonna cut this video short. If you want to play around with this one, I can save it under bouncy.html, so that you can sort of see the difference between what would be a like how these things learn compared to a bouncy space or a continuous space, or sorry, not a bouncy space, but a finite space with borders that bounce, or a continuous space like this one. You see they just sort of pass through to the other side. And this simulation has actually been running for quite a while, and there's quite a lot of predators here. So they've all sort of learned to hunt and move around within the context that all of these prey are just sort of going crazy. And the way the prey have learned to survive, if not much, because they... Let's see if we can find these... Any of the prey have negative scores? Well, not really. Everybody has a positive score. And are there some good guys in here? Well, kinda. The spread between all of them is not so much. There's not like one specifically that does way better than the others. Wow, yeah, that was slowing things down. Okay, so this video's over, but that's the key. That's the difference between these two things, and you can sort of see the difference in how these move around in order to get what they need or what rewards them.